This is going to be another example of how to solve a first degree ordinary differential equation using an integrating factor. This is just a little bit harder than the previous two examples. Remember, for solving problems using the integrating factor technique, you want to get the equation in standard form. That just basically means that the coefficient for y prime should be 1, and the coefficient for y should consist of x's and constants only, and all other loose x terms and constant terms should be moved to the right side of the equal sign. This is our example: x squared y prime plus 3xy equals sine x over x. It does say there for x less than 0. I'm just copying this example out of a book. This actually doesn't make a difference in how you solve the problem. It's just a domain for x that they want you to consider when solving this problem. There are other problems in which you do have a restricted domain, but for this problem, there's no difference in how you would solve it. This is the problem as it's asked. The only thing that I really can say that will make solving these type of problems more difficult is that you might not always see that your method or technique for solving the problem should be by using the integrating factor, and that's because usually if you're able to get the equation in standard form, then it will be very easy to see that, hey, I should use an integrating factor. But the problem could be written in many ways. For example, this is a second way to write the original problem, where the x has been multiplied through every term so that you don't have sine x over x anymore. And then furthermore, the sine x is moved to the left side of the equal sign, equating everything to 0. These two equations are exactly the same. Neither one of them are in standard form. Equivalently, the equation could also be written a third way, or a fourth way. And likewise, you'll see every single one of these are the same exact problem. They're just written differently, and so I just need to stress the importance of making sure that before you start solving that you put your equation in standard form. Thus, we can go ahead and start with the equation that's given to us to solve. Notice if we want to put this in standard form, we'll have to divide everything by x squared. That will leave us with y prime having a coefficient of 1, just like we wanted, and a p of x term of 3 over x, and a g of x term of sine x over x cubed. And when I say p of x and g of x, I'm just referring to the original standard equation that was given to you at the very beginning of the tutorial. Okay, after identifying the different parts of your equation, the next step is to make an integrating factor. You can always make this integrating factor by letting mu equal e raised to the power of p of x dx. And then we can just go ahead and plug in p of x, which is 3 over x. I pulled out the 3 in the antiderivative just to make it easier to solve. This becomes e raised to the power of 3 ln of x. Remember, we don't need the arbitrary constant c because we will be performing 2 more integrals and we really just need to tack on the constant at the very end. The 3 can be pulled to the outside, leaving you with e raised to the power of ln of x, quantity cubed. And this will all simplify to x cubed, since e raised to the power of ln of x is just x. Alright, I'm going to skip a step from the first 2 tutorials and just use this rule. You don't have, in the other 2 examples, I went ahead and multiplied everything by the integrating factor, but I mentioned in those videos that you can skip straight to this step. It's much easier and you'll show less work. If you want to see the way I did it in the first 2 videos, you can check those out. Otherwise, just skip straight to this step by using the rule. d of x of your integrating factor times y should equal your integrating factor times g of x. And so after filling in your integrating factor, which equals x cubed, and g of x, which equals sine x over x cubed, you're left with this expression, d of x of x cubed times y equals x cubed times sine x over x cubed. And remember, what we want to eventually do is solve for a y. So to start that, we should multiply everything by dx. And then take the antiderivative of both sides. Remember, on the left side, you have the antiderivative of the derivative, so that cancels out, leaving us with just x cubed times y. And on the right side, the antiderivative of sine x is negative cosine x. This time we do want to tack on the plus c. This is the last integral, and so we'll just include the c now as opposed to any time before. The last step here is just to divide by x cubed. The reason is because we want to isolate the y term so that we can get y equals something as a function of x. And you just divide by x cubed, leaving you with c minus cosine x over x cubed, your final answer. So you can go ahead and box that as your final answer. That's it. You can't really make these that difficult once you understand the process, because it works the same way every time. The only thing that could make it difficult is if you're not asked the question and given the equation in standard form, so you would have to put it in standard form before you begin. And another thing that could make this problem difficult is if you have a very nasty integral that you have to solve, which is very possible as well, but steps are all the same every time, and once you just memorize the process, you should be fine.